Hello good day viewers. In this tutorial we are going to learn how to evaluate one-side limit of a piecewise function. And we have a piecewise function here. F of x could be 0 for x less than 0. It can also be x for x greater or equal to 0 but less than 1. It can also be negative x squared plus 4x minus 2 for x greater or equal to 1 but less than 3. And it can also be 4 minus x for x greater or equal to 3. We are going to evaluate left and the right hand side limits of this function for 0, 1, 2, and 3. So let's get started. So number 1, we like to evaluate the limit as x approaches 0 from the left hand side of that function. And you should know that if you are approaching 0 from the left hand side, it implies that x is less than 0. So you need to find out where x is less than 0 from these four conditions. And this is only where x is less than 0. Therefore, we are going to consider 0. So the limit will approach 0. What if we want to evaluate the limit as x approaches 0 from the right hand side? So if you are approaching 0 from the right hand side, it means that x is greater than 0. So we need to find out where x is greater than 0 here. And this is exactly where x is greater than 0. So you should substitute the value of x equal to 0 in here. And when x is equal to 0, it means what? The limit also approaches 0. You can see the left and the right hand side limits are the same. Therefore, the limit of the function f of x as x approaches 0 alone also exists. Number 3, what if the limit approaches 1 from the left hand side of this function? It implies that what x is less than 1. So let us go ahead and find where x is less than 1. This is exactly where x is less than 1, right? So just substitute the value of x equal to 1 into x. And when x is equal to 1, we have the limit approaching 1. Number 4, we like to evaluate the limit as x approaches 1 from the right of that function. I forgot to include function here. So of f of x, which is equal to 0. So if x is approaching 1 from the right, it means that x is greater than 1. So let's find out where x is greater than 1. X is greater or equal to 1 here. So we are going to use this function. To substitute x equal to 1, we have negative x squared, that is 1 squared is 1, plus 4 times 1 is 4, then minus 2. Minus 1 plus 4 is 3, then 3 minus 2 is 1. Therefore, the limit is approaching 1, and you can see the left hand side and the right hand side limits are all the same. Therefore, the limit exists. Number 5, we like to evaluate the limit as x approaches 2 from the left of that function, which implies that x is less than what? 2. So let's go ahead and find where x is less than 2. So we can have x less than 2 in this boundary because the boundary is 1, 2, and 3, excluding 3 but including 1. So we have 1 here which is less than 2. Therefore, we are going to consider this function. So we have negative 2 squared is 4, plus 4 times 2 is 8. Then we have minus 2. We have minus 4 plus 8 is 4, and 4 minus 2 is 2. Therefore, the limit will approach 2 directly. This is equal to 2. Then let us evaluate the limit as x approaches 2 from the right hand side of that function. So we want to find out where x is greater than 2. The same place, we may have x greater than 2 here because I told you the boundary is 1, 2, and 3, excluding 3 but including 2. So we may have a value here in between 2 and 3 that is greater than 2. So if we substitute 2 here, we are still going to get 2. So this will approach 2 as well. And you can see the left and the right hand side limits are all the same. Therefore, the limit as x approaches 2 exists. Then the last category, we like to evaluate the limit as x approaches 3 from the left hand side of this function. That means x is less than 3. So where is x less than 3? X is less than 3 here. You can see it there. So we are going to substitute 3 into this function. We have negative 3 squared is 9 plus 4 times 3 is 12, then minus 2. Negative 9 plus 12 is positive 3, and 3 minus 2 is 1. Therefore, the limit will approach 1 directly. This is equal to 1. Then the last one, we want to find or evaluate the limit as x approaches 3 from the right hand side of this function. This means that x is greater than 3, right? So let's go ahead and find where x is greater than 3. This is where x is greater than 3. So we are going to use this function. 4 minus 3 is 1. Therefore, the limit will approach 1 as well. So this is equal to 1. And you can see the left and the right hand side limits are all the same. Therefore, the limit exists. So conclusion, if we have the limit as x approaches a from the left is not equal to the limit as x approaches a from the right, it means the limit does not exist. But if they are equal, we say the limit exists. Thank you for watching. Do share to your learner colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.